Hello, Gabe Heller here, Hohenzollern on YouTube and Hannah Brown Couch on Twitch, and I have an unboxing for you today. I found this at Micro Center. I wasn't looking to buy what the heck? I wasn't looking to buy one of these, or more accurately, I was not at Micro Center to buy one of these. But I have been looking for one for a while, so I figured I should get it, and it is an ECG 9-volt battery included DM850 digital multimeter with 10 amp / hold function / backlight, 6 function, perfect for workshop and school, and battery included. Ta-da! Let's see if we can get it open. It is in blister packaging. Wasn't quite that hard, but it was pretty hard, and that's probably not going to be enough. Oh no! This isn't the horrible kind of blister packaging. It actually opens. Yay! So here we have it. It is blue and black and red and green and white all over. It has these, and presumably somewhere is the battery which is included. These are the things which it tests. 6 functions: voltage, AC/DC, DC current, resistance, HFE, diode, continuity. DC voltage with many scales, DC current with many scales, AC voltage with not very many scales, resistance with quite a few scales. Alrighty, there it is. So I'm guessing that maybe the battery is actually inside it. Let us find out. Is there actually a battery inside it? Yes, there is. Okay. Do we have anything special that we need to remove? No, it's hooked up and everything. Let's hope it still works. I don't know how long this has been sitting at Micro Center. Okay. So here are probes, conveniently tied together. These are kind of crappy probes, but then I don't know what exactly I expected for 13 bucks. Actually, I can tell you in a moment exactly what I expected. How do I know where the red one and the black one goes? COM, voltage delta, special 1080. Oh my goodness. What does this say here? Stop testing voltage in current mode. Tear off before use. Okay. So I'm guessing that it doesn't have an awful lot of safety features. Maybe I need to read the manual. I would expect one of these to be red and one of these to be black. Maybe the red one's under here? Okay, I'll peel it off. Nope, it's another black one. Okay. Operator's Instruction Manual. Safety Information. Front Panel Description. 5. Number 5 and number 4. Number 4 is the COM jack plug-in connector for black negative test lead. Aha! COM. Number 5. 10 amp jack plug-in connector for red test lead for 10 amp measurement. And 6. Wait a minute. Where does this line go? It goes off into the black and disappears. I believe 4 is in the middle. That's what I was assuming. 4 is here, 5 is there, 6 is here. Okay. Plug-in connector for red positive test lead for voltage, resistant, and current, except 10 amp measurements. 10 amp jack plug-in connector for red test lead for 10 amp measurement. Okay. So it looks like the 10 amp jack is special for 10 amp stuff, and unless I know that I'm going to be doing 10 amp stuff, I think I just don't use it. Okay, so there we go. Ta-da! Let's see if the display comes on when I press buttons and turn things. Yes, we have a display. Hurrah! It reads by default 666, the number of the beast. So I have the tester of the beast. Why did I buy the tester of the beast? I bought the tester of the beast because this tester stopped working, and I need to fix it, and I can't fix it without a tester to test it with. So now I have a tester to fix my tester with. So allow me to demonstrate what is wrong with this tester. If I go into continuity mode, which one is continuity mode? resistance times 1, I think, doubles as continuity mode. It's also quite a cheap one. You will see that it does show continuity. Yay! But if I do anything else, let's say we want to test the voltage on this battery. That would be 1 volt, 9 volt, 10 volt, 50 volt. Okay, let's say 50 volt. Sure. Positive on that side, negative on this side, and what do we get? We get 10 amps. Oh my goodness, maybe it works. No, 10 volts. Okay, maybe that one works. But let's say I wanted to test a battery. If I switch it to 9 volt battery, it just tests off the frickin' scale. Look at that. Just way off the scale. And this is a dead battery too. This is one that doesn't have enough juice in it to run the smoke detector without it going beep. And yet, way off the scale. Here I have a 1.5 volt battery. This one's also dead. Which one's negative again? Positive on top. Yeah, that's what I thought. Okay, positive on top. And yet way off the scale. This battery is so good, it could run something for years, but it doesn't. It's actually dead. So something is clearly wrong with this tester. Now the question is, can we use this tester to fix this tester? First we have to get this tester open. These are not compatible, so I won't be able to use my slightly nicer test leads in my $13 tester. Goodbye. Okay. We have 2 screws here, one for the battery and one for the everything else. I think we have to take the battery one out first. There we go. This one runs on easier to find batteries, or not, on less expensive batteries than that one. Alrighty, there it is. And as you can see, there are components here. There's a component and another component, a component, and a component. And these are the kind of things I could use this tester to test. But let's first use it to test these batteries. One single 1.5 volt battery is all it takes to run this thing. Okay, so what we want to set this to is voltage. Now that's, I assume, alternating current, and this is direct current, because alternating is wibbly, wavy, sine wave stuff. 2. What does 2 register as? Hey, 1.6 volts for a 1.5 volt battery. That's pretty darn good. I think then we just pull these out. Kinda, maybe. Okay, got that end up. Got this end as well. There we go. Okay. So most of the components are on this side of the board. How can I view that side of the board? There we go. I'm going to want to be able to push down on it, so let's put something under here. Okay, cool. So we've got R1 through R15, 16, R1 through R16. Those are all resistors. Oh, that. There we go. Now you can see all of them better. Oh, we've got a stand here, so I'll extend the stand and point this toward you so you can see what's going on. But we want to measure resistance. Did a little experimenting with this before, and this seems to be the setting that gives me values, which is, it's weird because that's like 2 mega ohms, and I would bet most of these resistors are nothing near 2 mega ohms, but I don't know. I've had some troubles getting readings above that. Well, let's go to connectivity and make sure that the probes are working. That's not connectivity. Hello. There we go. Okay, cool. So what have we got here? I'm just going to test all of them because I don't know what they're supposed to be at, so I'm just going to test all of them and write them down and then try and decipher the markings, because some of these markings, 4R99, 1001, 47R0, 9530, I don't think those are going to actually prove to be the actual resistances. There's going to be like part numbers or something. So we're on R1. There we go. Hello. 0.002. Okay. And R2, we are getting 0.000. Okay. 0 ohm resistor, I guess. R3, we're getting... It's odd that it's a 0 ohm resistor, and yet somehow 0.001, and yet somehow it doesn't... well, maybe it would. Let's find out, actually. Does it make it go beep? R2? Kind of. Now we're getting a reading. Jumping all over the place, though, and I don't know what it means. The amount of continuity? Okay, R4. Is this going to be any better? It moves the decimal point around. Interesting. R4. Let's try it there. 0.05. Okay. R5. 0.94. Okay. R6. 0.01. 0.00. Another 0 ohm resistor. R7. 0.01. R8. 0.05. R9. 0.55. R10. 18.79. R11. Who knows? R11. Aha! 0.029. R12. 0.049. R13. 0.198. R14. 0.198 as well. R15. 0.224. And R16. 0.271. Okay. And then we've got a diode, D3. What do you just measure a diode by measuring its connectivity? Is that right? It should connect one way and not the other, right? Isn't that what diodes do? It apparently makes the thing run. Can you hear that? The gauge is running. Gauge is flopping back and forth when we do that. It won't be easy to show you. Let's see if I can. There. Covers it up. What about the other way? Well, maybe you can see it. I don't know if I can. So, when we do this way, nothing happens. When we connect this way, the gauge moves, I think. Maybe not anymore. Yeah, no, it's moving. Okay, cool. I guess. I mean, I don't actually know precisely what's supposed to happen there. And then on the back, we've got two more diodes, D2 and D1. We get a reading this way on D2. And this way we should not. the dial's going again. So maybe the diodes are working if they only move the dial when we send current in one direction. This one's not moving the dial, but maybe it's not connected to the dial. I don't know. Does D mean dial or does it mean diode? I don't know. It seems to, yeah, interesting. Okay, so that's that, and then we've got R0, another resistor. Which gives us 0.004. And then we've got J1, which, what, it's a jumper? It looks like a component of some kind. It does seem to have connection, but no matter which way we go, we'll see if it has any resistance. It has almost no resistance. Okay, so I'm not sure why you would have a jumper that's a component, unless it's like maybe a 0 ohm resistor. It does, I mean, it's the same color as the other resistor. It's surface with this through-hole mount here. So maybe it is a resistor and just a 0 ohm resistor. Is that what one black band means? This is the point at which I'm going to look all this up, and hopefully I will come back to you with the result of one of these being wrong. Okay, so I've learned an awful lot. I hope it is all correct what I have learned. So the first thing I've learned is that the range on the, well, so that there's a dot that moves around on the screen, and it's not always a decimal point. Sometimes it represents a comma, or you're at a new range that's like kilo ohms now. And I'm not sure how you tell what the range is, except that the dot just kind of moves around a little bit as you go. Yeah, it's weird. I believe I've identified 4 resistors that are not in spec. Bad? I don't know. They still seem to resist and kind of close to what they're supposed to resist, but not nearly as close as all the rest of them. So these 4 are the ones that are furthest out. R0, R2, R6, and R7. I went onto the Digi-Key website, and they have a place where you click in, type in the codes, and they will tell you what they mean. And if I'm typing the codes in right, green, red, orange, brown means it should be 5,230 ohms, and it's coming back as 4,160 ohms. Then this one, 4R99, is marked with letters and numbers, and that's supposed to mean 4.99 ohms, but it reads as 5.5. Then we've got one that's, if I'm reading it right, and some of these are pretty hard to read, there's some schmutz on them. We've got one that seems to read 6R98, which would make it 6.98 ohms, but it's reading 4.4 ohms. And another one that looks like it says 9R09, which would make it 9.09 ohms, but it's reading 4.4 ohms. And so these 3 at least are low resistance, so I'm going to measure them using the low setting here, and this, in this case, the decimal point actually is a decimal point. Okay, so we've got R2, which is indeed reading 5.5 ohms, and it's supposed to be 4.99. And we've got R6, which is indeed reading 4.4 ohms, even though it is supposed to read 6.98. And then R7, which is also reading 4.4 ohms and is supposed to read 9.09. Okay, and then the one on the other side is also a bit out. This one here, I have to change to there to get a reading off of it at all, because it's a much higher resistance, much higher ohm resistor. But I'm getting 4.16, and I believe we're at kilo ohm range here. I have no way of knowing for sure, but that seems to make sense in terms of all the other readings that I got, which you saw earlier. And so 4160 when it should be 5230. So I'm going to try and replace those 4 resistors, and we'll see if that fixes it. Back in a bit. Okay, so I'm kind of excited. This is the first time I've ever ordered a package or gotten a package from Digi-Key. Let's see what's inside. Hopefully it is the stuff that I think I ordered. It's kind of a little complicated using their website, especially when I never ordered resistors before. There's the, what? I follow the arrows? I don't know. They use interesting packaging. Fans. Ooh. Okay, we have envelopes. Here we have an envelope, and in it there is, now I ordered 2 of everything. I don't know if that means it's going to be, okay, so there's 2 in this envelope. And there it is, and it is 4R99 resistor, which I believe is one of the ones I need. Okay, and in here we have, boy, there's so much Japan, lead-free. Oh dear. Come on. There it is. That. 6R98. Here we have a 9R09. Here we have, yes, they look right? I think they look right. 4.22 kilo ohms. All right, so I guess let's get out the soldering iron and see if we can finally fix our multimeter. Don't forget, the red wire came off. Oh no. Yeah, the red wire came off. Time to open it up. Did you ever find that knife on the floor in the front room? Okay. Here we are, and yes, the red wire has become disconnected, so we're going to need to fix that as well. Looks like it goes there. M plus, okay. Huh. Why is it stuck? Who knows? It's not stuck anymore. Okay, there we go. Okay, here we are. And on this side are all the resistors that need to be replaced. And here are some resistors. And they are bigger than those. I was afraid of that. I did my best to measure them. This is the first time I've ever measured them. They are in a tiny little something. I'm guessing this is the strip from which they were cut. How do I get them out of this tiny little something? I only want one. Well, I've separated them, one from another. Oh, and the plastic seems to have come off, I believe. Yes, so here we have the actual resistor. Okay. Here's where I have to take my glasses off to see the thing. This is a 6R98. Is this the one? No, that one's still got two in them. Okay, so we're done with this for now. 6R98. So where does the 6R98 go? 6R98 is R6. Is that the only one? Is that the one that's bad? Somewhere here I have notes. More resistors. Here we have the notes. Okay. So 6R98 is R6. Yes. Okay. There it is. R6. Okay. Let's try and get it off of there. Oh, it does have a setting 1 and setting 2. I don't know what those are, though. Does it say what they are? No. 2 level. It simply has 2 levels, 1 and 2. Looks like I could maybe even, like, tweeze it onto the thing and it might stay. Ha ha ha. Because they're spring tweezers. R6. Oh wow, no, it is way too flush. And these are way too. Well, I mean they've got gunk in them. Maybe I could file the gunk off and make them pointier. Let's find out. Use a little bit more. That is definitely sharper. Is it sharper enough? Nope. Maybe this shouldn't be quite so near here. Nope. Well, I don't think I'm going to get a whole lot sharper than that, so I guess I can't just leave them on there. I'll have to use them as I go. I don't want to melt the case, so we'll keep the case as far away from here as we can. Okay, here it goes. We'll try one first. I don't like these these tweezers. I need something that I can actually make do what I want. Well, my pinky finger is getting hot. Hopefully the board is also getting hot. If I hold it up, then hopefully the board will just fall off the bottom of it. Unfortunately, my fingers are starting to get hot. So now I need some kind of insulation for my fingers. But somehow I can still hold the tweezers while using. I think people who do this professionally have ceramic tweezers, I think. But I don't have any ceramic tweezers. Well, that's just way too long to have to wait. I think we're going to have to go to 2. One, 1,000, 2, 1,000, 3, 1,000, 4, 5, 1,006, 1,007, 1,008, 1,009, 1,010, 1,011, 1,012, 1,013, 1,014, 1,15, 1,016, 1,17, 1,18, 1,19, 1,20. 1,001, 1,002, 1,003, 1,004, 1,005, 1,006, 1,007, 1,008, 1,009, 1,010, 1,11, 1,012, 1,013, 1,014, 1,015, 1,016, 1,017, 1,018, 1,019, 1,020, 1,021, 1,002, 1,003, 1,004, 1,005, 1,006, 1,007, 1,008, 1,009, 1,010, 1,11, 1,012, 1,013, 1,014, 1,015, 1,016, 1,017, 1,018, 1,019, 1,020, 1,021, 1,002, 1,003, 1,004, 1,006, 1 1006, 1007, 1008, 1009, 1010, 1011, 1012, 1013, 1014, 1015, 1016, 17, 1018, 1019, 1020. Nope. 1, 1002, 3, 1004, 1005, 1006, 1007, 1008, 9, 1010, 1011, 1012, 1013, 1014, 15, 1016, 1017, 1018, 1019, 1020. 1001, 1002, 1003, 1004, 1005, 1006, 1007, 1008, 1009, 1010, 1011, 1012, 1013, 1014, 1015, 1016, 1017, 1008, 19, 1020. Nope. 1001, 1002, 1003, 1004, 1005, 1006, 1007, 1008, 1009, 1010, 1011, 1012, 13, 1014, 1015, 1016, 1017, 1008, 19, 1020. 1001, 1002, 1003, 1004, 1005, 1006, 1007, 1008, 1009, 1010, 1011, 12, 1013, 1014, 1015, 1016, 1017, 1018, 1019, 1020. 1001, 1002, 1003, 1004, 5, 1006, 1007, 1008, 1009, 10, 1011, 1012, 1013, 1014, 15, 1016, 1017, 1018, 1019, 1020. Nope. I don't know. At that rate, this is going to take forever, so I guess we don't use hot air. I probably have to use a solder gun. What do I do with this? There's no way it's going to just stay steady. Boys just have them attached somehow. What do they do? How do they attach to something? No idea. I guess it's just going to sit here like this. Of course, we've got two ends to do here. It's smelling more and more hot. Still can't tell that this is moving at all. Nope. Just out of curiosity, let's. Oh, hello. Yeah, I mean it's covers basically the entire box, but I think it'll work. Hey, it came off. Hoorah. The other end just sticks up because it broke off. That's right, we gotta make sure it's upside down because the rest of them are also upside down from my perspective. There we go. Okay. I got the little piece of resistor off. It's now permanently on the end of these tweezers. Okay. You just don't want to sit there and do it. It's going to ping off in every direction imaginable. Is that right side up or upside down? That's right side up. Still right side up. Nope, whatever this is did not actually come off. It's still there. And somehow it's right side up again. Not staying in place. What is more, we also have to replace R7, which is this one right next to it. So I think these resistors may just be too big because the two are right next to each other. I'm not sure I see any way to avoid that. Unless it turns out R7 is actually good and R6 was somehow messing up our readings for R7. We can test this other resistor here, I suppose. See if it tests correctly out of circuit. And if it does, put it back on and only replace the other ones. $15.31, and the new one, 0.01. Yeah, no, they are definitely not the same at all. It doesn't matter if we test the other direction. 0.01. One point. What is this even reading? What does this mean? Why do you say 1 point, no matter what I do? That doesn't seem like that could possibly be correct. Okay, so 0. How about here? 0.01 here. Am I going the wrong direction? No, those are mega ohms. Kilo ohms. 200 ohms. Back. 8.3. 8.3. Maybe they are the same. Maybe this one is working. But now it's stuck at 1 again for no apparent reason. Hello? Why are you stuck at 1? What is going on? Now it's 7.5. 7.4, what are you? Also 7.5, 7.4. I guess we put this one back on. Well, certainly this is correct. Okay, I think we've successfully put it back on. So now what? Well, that was this one here. So we'll put it back in here. If I can find it, there it is. And we'll move on to the next one. Okay, so the next one is not coming apart nearly as easily as the first one did. There it is. And this one is 9R09. 9R09 is R7. Okay, so we take R7 off. Hey, got that one off. Cool, let's test those. see 7.234, something like that. Okay, this one's reading 9.5. Okay, so this one's definitely bad. Yeah, that's not anything like that. So this one definitely needs to be replaced. So Sarah's here helping me.
I'm not holding it, hold on.
I have no idea how people do this with only two hands. Even with helping hands, that would only hold the board in place. Fortunately, I don't have to worry about the board. I think it's just going onto the soldering iron. That's why people use flux. To help the solder go anywhere but onto the soldering iron. But guess what? Flux requires another hand. Maybe it doesn't, but how was I doing this before? I don't know. Somehow it reached before. Okay. Now let me see what kind of situation we have here.
Are we gonna lift the tongs?
Not yet. I don't think I got any on the right hand side.
This is lead solder.
I don't know. What is this? This is lead-free solder.
Right.
We got a giant blob of solder. It doesn't look like it's contacting anything else. I don't know that it's actually making contact with the pad, though. Next one. It's already loose. This one is 4R99. 4R99 is R2. Okay. Let's get R2 out of there and see what it measures. Actually, let's check it first. We may have fixed one, but at the very least we've taken a bad one out of circuit. So maybe R2 measures correct now, and we don't have to replace it. Wouldn't that be nice? Okay, so 4R99 measures 5.4. Okay, sure it does. .5. So R2 is probably good. And then finally we've got the one on the back. The bag says this is a 4.22 kilo ohm. And we were replacing a 4160 ohm. Let's see, our 4.16. Okay. So they don't actually have the same markings because they're a little off. This was 4220 and I'm replacing a 4160. That was the closest I could get. Okay. So this one is reading. Hello? Boy, it's hard to get my probes on it. Reading nothing. Not reading at all. just reading 1. How about here? There we go. 4.14. This is supposed to be 4.22. Okay, so it's actually closer to, in real value, to this one than it is supposed to be. So good for that. And this one's also reading 4.16. So this one is probably also good. It was just that one that was bad, and it was throwing off the readings on the other 3. So assuming we managed to attach it properly, which I don't even know if we did, then maybe it works. And maybe at the very least, some of the functions work, and just the functions that require that one resistor are broken. We can always hope. So now all I have to do is reattach the wire. Okay, so the wire is supposed to be attached to that there. And it's important that neither of these wires, wow, it's stuck somehow, okay. It's important that neither of these wires go underneath, correct? They both have to go above, like that. There, that's how it's supposed to go. Not underneath, but above. There. Okay, that looks correct. This needs to go back where it goes before we put this in place. Hello, dial. There we are. I need to strip this wire. Even this, well, no, the smallest one is too small. Okay, so that's good. Let's try a bigger one. Okay, maybe the next biggest one. There we go. We have stripped the wire. Now we want to put that wire in this hole and solder it in place. The hole is probably full of old wire. Yeah, it seems to be. Also, one strand of the wire is longer than the rest of the wire. Get it? No, of course I didn't get it. Oh, maybe I did get it. There we go. Definitely got it that time. Okay. So when I clear this hole out of solder and stuff, I'm just poking the soldering iron directly down into it. Okay, hopefully that worked. Can we now poke the wire through? Probably not. Now if we tin the wire, that should help. Let's see if we can tin the wire. Okay, I have here my drill. I don't know how much you saw. I was running out of space. I have my drill on the smallest drill, but I have. I'm going to drill this hole out. There. And I'm just going to hope that the solder that I put in is going to fill up that hole and make all the connections necessary. All right, you. Some of the solder is already on the wire. wire goes in, the wire doesn't go in. The wire goes in the hole. The soldering iron goes on the wire. The solder goes in the hole. Eventually, solder goes nowhere at all. The solder is now not straight. The wire comes out of the hole. The wire goes back in the hole. The wire goes back in the hole. Wire's in the hole. Solder bends again. Solder melts, but only because it's touching the soldering iron, which means it's probably not actually going in the hole. Solder actually goes into the hole next to the wire, and now I'm just going to melt it somehow. Nope. The wire is still loose. None of this worked. Impossible. Absolutely impossible. No. And the wire comes out of the hole again. The wire goes back in the hole. The wire comes back out of the hole. The wire goes in the fucking hole. Nope, the wire just does not go in the hole anymore. My computer downstairs makes random noises for no reason. What does it mean? God knows. Lots of solder melts in the vicinity of where it's supposed to be, but none of it actually goes in the right place. And then I kind of let it drop into the right place. It's holding the wire in place. Is it making a connection? I have no idea. But it's holding the wire in place. So let's try it. Unplug the soldering iron, but that would be tempting fate. Cover needs to like go on in a weird way, which it won't. There we go. Which way does the thing go? That way.
Just to let you know, this video is over soon. So rub your eyes and stretch your thighs and sing in tune. It's time to find another kind of video, for this one is nearly done, you know.
Okay, here we have probably a not working, but let's find out, tester. Oh, I'm going to unplug the soldering iron now. Minus goes here. Plus goes here. It is a 9-volt battery. It should be close to 9 volts. So I switch this to 9 volts. Does anything register? It does. But it's way off the scale. So we haven't fixed anything. It's still doing exactly what it was before. Now maybe we're at the point where the adjuster will actually adjust this properly. Are we? Can we adjust this anything like... Nope, we simply can't. I'm getting accused online of not knowing how to read this multimeter, which frankly I never read the manual for it because I thought I was going to use it to fix this one, which I know how to read, and then probably never use it again until maybe buy a better one that tests a bunch of other things. This was just a quick purchase that I thought might solve my problem. Well, I don't know what to do about this, and I've got to make progress, so we're going to flip a coin. We might end up flipping 2 coins. First coin, how does even less fit in there than when I took a coin out? I'll figure that out later. Okay, so what's heads and what's tails? That's heads. It's got a head on it. Okay, cool. That makes it easy. So yeah, heads. I end the video here, and I let you guys in the comments decide what you think I should do next. And tails, I flip another coin to decide what to do next. So here we go. That's tails. Okay, so I flip another coin to see what I do next. Heads, I order parts from Digi-Key and hope they work. And tails, I just buy a new multimeter and I go to the trouble of looking through all the multimeters that are available online. Oh my God, there's so many of them. And figure out which one to buy. Ah. Try that again. It's tails, so I'm buying a new multimeter. I'll see you in the unboxing.